Okay. Hello again. This is 4.6C. So we've been doing a lot of stuff here. This is the same thing as 4.6B. Solve it and graph it, test point, shade, except the way the problem is written. This one is not written in y equals mx plus b form. It's written rather in standard form. 2x plus 3, and make this correction, that should be a y. I apologize. That's a typo on my part. 2x plus 3y is less than 6. Well, think of that as 2x plus 3y equals 6. And we're going to graph this using intercepts. That's where you find the x-intercept by putting a 0 in place of the y. So remember going 2x plus 3 times 0 is 6. In other words, that's 0, so it doesn't exist. You're just left with 2x equals 6 or x equals 3. That's your x-intercept. So over on the graph, I can mark 3 on the x-axis. My y-intercept would be like pretending like the 2x is not there. So I have 3y equals 6. Again, just pretend like the 2x is not there. So y is 2. My y-intercept is 2. I can go over there and mark that point. Now, to graph your line, be careful. This inequality symbol at the top is not underlined, so I want my dotted line. Now let's do my test point. My favorite is 0, 0, which is right there. So I plug it in. 2 times 0 plus 3 times 0, is that less than 6? Well, that means 0 plus 0, which is 0, is less than 6. So ask yourself, is 0 less than 6? That is a yes answer, which means this blue dot over here is my yes side. The other side becomes my no side, and I always shade the yes side. Always shade the yes side. So the only thing different with this worksheet compared to the last one is the way the problem is written. On 4.6b, it's written in y equals mx plus b form, slope-intercept form. These are written in standard form. So we do intercepts. With this next one, you should be able to see 3x minus 2y is greater, I'm sorry, put an equal sign in there. Equal sign. Well, if you pretend like the 2y does not exist, you should see 3x is 12. In other words, x would be 4. The other one would be a minus 2y is 12, or y would be negative 6. And there's my two intercepts. X is 4. Let's go over and mark that. X-intercept is 4. Y-intercept, negative 6. That's way down here. It's not underlined, so we draw a dotted line, or a dashed line. Dotted, dash, same thing. Now my test point, I'm going to mark 0, 0 right there. So let's plug this in. 3 times 0 minus 2 times 0 is greater than 12. Well, that would be 0 minus 0, which is 0, is greater than 12. Is that a true statement or a false statement? Is 0 greater than 12? And I would say that's a no. So my blue dot over here becomes my no side. The other side becomes my yes side. And of course, I always shade the yes side. Hit the pause button if you would. You guys work out the next one on your own. With this one, I should be able to look up there by now and tell that the x-intercept is 5 and the y-intercept negative 3. X-intercept 5, y-intercept negative 3. That's just pretending like the opposite one does not exist and solving it. So let's mark those. X-intercept is 5. y-intercept negative 3. That is a underlined symbol, so now I can draw a solid line. Test point right there, 0, 0 will work. That means that 3 times 0 minus 5 times 0, is that less than or equal to 15? Well, that would mean 0 minus 0, which is 0, is less than or equal to 15. So is 0 less than 15? That is a yes answer. So this would be my yes side. That becomes my no side. Shade the yes side. And you're done. One more. You guys hit the pause button. Try this last one on your own, please. This one, x-intercept, negative 3. Y-intercept, negative 2. Let's graph those. X-intercept, negative 3. Y-intercept, negative 2. It is underlined. Solid line. Test point, right at 0, 0. Plug that in. 4 times 0 plus 6 times 0 greater than or equal to a negative 12. 0 plus 0 is 0. So ask yourself, is 0 bigger than or greater than negative 12? And that is a yes answer. So I would shade this side. This would be my yes side. So that would be my no side. Okay, good luck with those. Thanks for watching.